What if you could run at the speed of light? First, congratulations. You've just broken every known law of physics. Einstein would like a word, and he's probably shaking his head somewhere in the afterlife. But let's ignore the fact that you've just rewritten the universe's rulebook and focus on the more important question. What actually happens when you start sprinting at 299,792,458 meters per second? The first thing you'd notice is actually you wouldn't notice anything because the moment you hit the speed of light, time, for you, slows to a crawl. From your perspective, the world around you freezes. That's great if you want to photobomb someone in the middle of their sneeze, but there's a catch. To everyone else, you've effectively disappeared. They'd see you as a blur of energy, like a lightning bolt had developed a gym membership. Now let's talk about the air. Normally, when you run, air molecules politely move aside to let you pass. But at light speed, you don't push through air. You annihilate it. The molecules in your way are smashed apart into plasma. You've just turned your morning jog into a miniature nuclear explosion. Congratulations again. You've now vaporized your neighborhood, and that's only from your warm-up lap. Your shoes? Gone. Your clothes? Instantly shredded by the unimaginable friction. Even if you wore a spacesuit, it would turn to ash before you reach the end of your driveway. If you're shy, this is a bad day. If you're a streaker, it's your moment to shine. Literally, because your body is glowing from the heat of ionizing the atmosphere. You also have another problem. Energy. Moving at light speed requires infinite energy, which means you're burning through calories faster than the universe can provide them. Even if you ate the entire contents of a supermarket before your run, you'd run out of fuel after taking a step the size of an atom, which, at light speed, is still a journey across the planet. Speaking of the planet, let's say you somehow keep going without disintegrating into a puff of subatomic particles. In just over 0.13 seconds, you've run around the Earth. In 1 second, you've done it 7 times. In a minute, you've circled the planet more than 400 times. This is great if you want to see every landmark in the world, but at light speed, you can't exactly stop to enjoy the view. Stopping, in fact, is a whole new nightmare. If you tried to stop instantly, your kinetic energy would be released all at once. That energy would equal more than the most powerful nuclear bomb ever detonated. Cities would vanish, continents would shake, and you'd probably leave a small but extremely inconvenient crater where you used to be. On the bright side, stopping gradually over several thousand kilometers might reduce the destruction to only a few small countries. And then there's the question of what your brain would experience. At such extreme speeds, the world in front of you is compressed into a blinding wall of blue shifted light, while everything behind you stretches into darkness. Your eyes aren't built for this. Like, the photons hitting your retinas would have enough energy to fry them. And since sound can't travel fast enough to catch up to you, you'd run in complete silence. Imagine the quietest, loneliest run ever, except the silence is because you've outrun sound itself. Finally, let's think about where you could go. In theory, you could reach the moon in about 1.28 seconds. You could run to Mars in under 13 minutes, to Pluto in about 5.5 hours, and to the nearest star in just over 4 years. That's right. Even at light speed, space is ridiculously big. So, yes, you could run to Alpha Centauri, but you'd still need to pack snacks. Infinite snacks. The lesson? While running at the speed of light sounds like the ultimate fitness flex, the reality is you'd destroy the planet, blind yourself, starve to death in a fraction of a second, and still be late to anything happening outside our solar system. Sometimes it's better to stick to a light jog. That way, the only thing you'll break is your personal record, and not the laws of the universe. If you enjoyed this little trip into impossible physics, give it a like so the algorithm doesn't treat it like a vacuum. And subscribe for more ridiculous science questions.